Hi everyone. This week we are going to talk about methods for displaying and visualizing digital elevation models and imagery in ArcGIS Pro. There's lots of fun tools that allow us to sharpen up images so that the contrast, the brightness, and the detail is much better than when we originally add the data to ArcGIS Pro. I think many of us have gotten into the habit that as soon as we add imagery to Pro, we think that's it, and there's more to it than that, because when we do create map layouts that are going to be consumed by other people, and they have reasons to interpret that, enhancing your imagery is a really good thing to do, so that again it just makes your imagery look more crisp and provides for the detail. So before I move on from the screen, what you're seeing here is actually an enhanced image of central Pennsylvania. This is our Valley region of Pennsylvania, and this is actually a digital elevation model over top of a DEM, and then there was a lot of contrast stretches, or not a lot, there was a contrast stretch applied to it, and some other tools to just make it look a little bit more sharp. And this is actually what I use for my Zoom background oftentimes when I'm in meetings. So we are going to start by reviewing what a digital elevation model is. For those of you that took the intro class last semester, you were introduced to DEMs, and you learned how to generate a number of data sets from a digital elevation model. For those of you that were in remote sensing last semester, we continued talking about what we can do with DEMs, and we also use LiDAR data to, again, understand the Earth's topography a little bit better. This part of looking at DEMs, we're going to focus a bit more on now that we have the data and so forth, and we have the data sets, how do we display them on a map, so that again it creates a really good visualization for your map audience. But a digital elevation model, or a DEM, is a representation of the Earth's surface. Essentially, this is an image file, and as you know, image files are comprised of pixels, and so each pixel has an elevation value attached to it. And because of that, then we can use this data set as the starting point to do terrain analysis. This is how we create those other data sets like slope, aspect, view shed, contours, and so on. So it's really, when we talk about terrain, this is the data set that we really need to know about. There are many different types of DEMs and resolutions associated with digital elevation models. You're going to come across 1 meter DEMs, 10 meter DEMs, and 30 meter DEMs. And so what that means is that each pixel represents either 1 meter, 10 meters, or 30 meters. And obviously the one that is going to give you the crispest image is going to be the 1 meter, and then the 30 meter would give you the least crisp. It also means that the analysis that you do is going to be better at the 1 meter than the 30 meter level, because again, that 1 meter is looking at 1 meter of surface area on the ground, and 30 meters is obviously a lot bigger than that. Just a reminder that a digital elevation model is raster data. It's not a shape file, it's not a point line or a polygon, so you have different file types associated with that. And you're going to see all of these file types associated with DEMs and other raster formats. And this is a digital elevation model in Hillshade again of Bighorn Canyon National Recreation Area, and I'm actually going to use this as one of my examples as I go through and show you how to combine the data sets to create a nice terrain visualizations. So just to go through a couple of reminders about how we interpret digital elevation models. When we add a DEM to our map, we always see this elevation range associated with it. And the elevation range, it means that in this particular image that I have, the lowest elevation in that spatial extent is 837, and the highest is just a little bit over 4,000. But that's not kind of enough. We have to know the units, or that means absolutely nothing. And you have to make sure that when you are putting and using this data on your maps that you are specifying units, because feet and meters are not the same thing, and it could be people could be assuming different units, so make sure that you're always putting the units on your map layout. To find out the units, there's a number of different ways of doing this. A quick way is after you add your DEM to ArcGIS Pro, if you come to your layer properties and go to your source tab, it will tell you your vertical units. It's also in the metadata, so like when you go and download, I mean, you're going to know even before you bring this into ArcGIS what units they're in, if you take the opportunity to look at the metadata. So this is very key to know up front is what you're working with. Also, you can also get the resolution from here, and I don't have it expanded out here, but you can go to the same source option, and under raster information it will tell you the X and Y size and for a cell, and that is equal to the resolution of your image. So you can find out if it's 1 meter by 1 meter or 10 meter by 10 meter. So just to do a little bit of a comparison of what it looks like when we have a 1 meter digital elevation model versus a 10 meter digital elevation model. You can definitely see a lot more detail in the 1 meter. Like over here in the 10 meter, we don't really see the road cuts, but we can see those in the 1 meter. And you can kind of see them a little bit too in the 10 meter, but just not as distinctly as you can in the 1 meter. One of the trade-offs that you are going to have to concern yourself with, and this has to do even with your Yellowstone project, is what resolution do you need for the project that you are working on? I would argue that you do not need 1 meter data for the Yellowstone project, because it's a larger spatial extent and you're not going to be that zoomed into it anyway, so 10 meter is likely going to be sufficient. And also, not every place in the United States has 1 meter data available. There are areas that only have really a 10 meter or a 30 meter, so sometimes you're limited by what is actually available, and we'll talk about data availability here in a second. On the website that you're going to be going to, I would suggest getting the 10 meter ones. So sources for DEMs and LiDAR data, both are USGS's LiDAR Explorer application, and I have a separate video posted that shows you how to use LiDAR Explorer to download digital elevation models, so I'm not going to go over that here. I have that as a standalone thing because I figured it might be more convenient that way, so that if you have to go back and watch it a couple times to get the process, you don't have to go through a really long video. You have a much shorter video to go through to do that. You can also get DEMs from the NRCS Geospatial Data Gateway. This is actually a lot easier than LiDAR Explorer, so if you want a little hint, I think the Geospatial Data Gateway is a lot more intuitive to get what you might need for your area of interest. And then you can also get them from state data clearinghouses, like Pennsylvania would be POSDA, and POSDA got cut off on my screen there. So again, I did post a video showing how to use LiDAR Explorer to find DEMs, but this kind of just goes through the basic steps that you will go through in order to find digital elevation models for your area of interest. You can also use the NRCS Geospatial Data Gateway to find DEMs. Essentially, you go to this website, click on the Get Data, and then under Get Data, you would select your state and what county, and Yellowstone I will actually, I should let you figure that out, because you can easily figure out what county and state is, and I don't need to tell you that. But once you figure out what county and state Yellowstone is in, select that, and then you have a number of different categories to select from, and one of them is elevation, and the one that you would want is the National Elevation Dataset 10 meter. Again, this might be the easiest way to download your digital elevation models, but that's, my interpretation of what's easy. Some of you might decide that this is easier, so I'll let you pick which method that you want to use. But when you do finally find your digital elevation model, you then of course add it to ArcGIS Pro just by clicking Add Data. And for a number of different areas, you have to download more than one DEM to get the spatial extent for your area of interest. For example, here in Yellowstone, you can see that there's a couple of different DEMs here. And so what we would have to do then is mosaic those digital elevation models together so that we have one DEM that we're working with versus all the ones that you see shown here. Once you do add them, the DEMs to your map, like I said, you can mosaic them, and mosaicing is essentially stitching together the adjacent data sets. And the tool that you want is right here. You would go to your analysis toolbox, follow this crazy path here, and then go to Mosaic to New Raster, or in ArcGIS Pro, you would just do your search and click Mosaic to New Raster. Now, a little bit of a warning here about Mosaic. You are going to see a number of Mosaic tools listed in Arc Toolbox. They do function differently, and really pay attention to the name of this one. It's called Mosaic to New Raster. That means is taking all of these input data sets, the individual data sets, and it's not impacting them in any way. You are creating a whole new data set that is a whole new file. That's very different than the Mosaic tool, which will take one of these existing files and then append all the others to it. So it actually changes the nature of one of these files, and you don't normally want that. So just be careful when you're selecting your Mosaic tools. Alternatively, there's another way to do mosaicing that I'll show you in a second. But when you do mosaic your DEMs together, you get one big data set, and what you should see is a data range that takes the lowest elevation value from your input data sets and your highest, and it stretches them out over that range. So if we come back here and look at these, we can see that the 10, 38, 39 is the lowest elevation, and we don't have to see them all on here. There's actually one that's missing there, and it's taking then the highest range of that, which is like the 3897. So just so you have the conceptual idea of what is happening there. I'm actually going to switch to ArcGIS Pro here for a second, and let me find just a DEM to look at, and I think I'm selecting the wrong project here. And let me just pause this for a moment. So when we use this tool, the Mosaic to New Raster, we come to our tools and we look for our Mosaic tool. Oops, I did exactly what I told you guys not to do. Select the wrong one. Mosaic to New Raster. And then you input the rasters, which will be these two. And notice that how you have your seam here, because that seam exists because the elevation ranges aren't the same, so you're going to see that happen. I'm going to put the output location to be in a folder. and then I'm going to name it and give it the file extension. And I'm going to do an IMG. I'm a big fan of IMGs. It's the easiest. And then you select the spatial reference for the raster, and I'm using the same as one of the input data sets, and they're both the same. Now the reason I wanted to show you this was because of this option here, the pixel type. The habit a lot of times is to take the default, and the default doesn't always work in this case because the 8-bit unsigned isn't always enough in terms of bit depth. So we have to select something else, and I select the 32-bit data type because it supports decimals. You want something that supports decimals because this isn't round numbers. So I'm going to go down and select 32-bit float. The cell size is 10 meters, but you don't have to actually put that there. This only is 1-band data. Aerial photos would be 3-band data, and then Landsat images and Sentinel images would be depending on how many bands you put in your composite. But we're not going to be working with those with mosaicing this week, so don't worry about them. And then I'm going to keep everything else the same, and I hit run. But the thing that I want you to know mostly on here is the pixel type and the number of bands to select when you are building or when you are mosaicing a raster or a DEM raster data set. And this will just take a moment. Or it might take 2 moments, it appears. I thought this would be a little quicker with just 2. Now that it's added to the map, what you can see is that the seam goes away. And you also see that it took the lowest elevation value of the input rasters and the highest elevation raster or elevation and stretched it out to create one raster data set. So that's how you would use the Mosaic tool, and that's something you're going to want to do for whatever DEMs that you download, because you likely will need more than one DEM to cover the Yellowstone study area. Now, displaying and rendering DEMs is a lot of fun, and it can be a little addictive once you get started playing around with these. And the first thing to know is that there are a lot more color schemes available in ArcGIS Pro for symbolizing topography than there was available in ArcGIS or desktop, or ArcMap. So you are going to see that there are more options. The other thing that we are going to talk about that we didn't really talk about too much in intro, actually I don't think we talked about it at all, and we did talk about in remote sensing, is the concept of stretching, resampling, DRA, gamma, and then adjusting, transparency, brightness, and contrast to basically make your image look better. So let's go to ArcGIS Pro again, and let's go to this project, and I'm going to start here. This is Bighorn Canyon National Recreation Area, which is located in both Wyoming and Montana. Yellowstone's actually like right here. It's just right off this digital elevation model. And right now we just have a DEM for this, and we take a look at the DEM properties. We're going to find information that we need to know about it. If we go to our source tab, we find that the vertical units are meters, and then if we want to see how what the spatial extent is, we can go to cell X and Y, and it's 10 meters is what this data is. So we're working with USGS 10-meter DEMs. So again, this is the starting point for terrain analysis. In intro and remote sensing, you learned about how to symbolize digital elevation models. You would go to your symbology and then go to change the color scheme. And if you remember, you can, when you're on your color scheme, I got to move this out the way for that to show. You can go to show names, and this is really helpful when picking color schemes that are appropriate for the phenomena that you are interested in. And again, notice here how all these different schemes that I have available. I'm just going to select Symbology 7. And this looks kind of crappy, really, the way that we see it, but I'm just going to keep it there for now because I think we can make this look a lot better. One of the ways that we can make this represent topography much better is by then creating a hillshade data set from the DEM. So if I turn off my DEM and turn on my hillshade, we get this hillshade, which still doesn't really look overly awesome. Again, this gives us kind of the the terrain looking feel of the area. But what we can do is we can combine the DEM and the hillshade to create a nice visualization. So the way that we do that is come back up here to the DEM, and then we have our transparency function here. So we just pull our transparency so that we can kind of see that underlying terrain. And I'm actually going to take the park off just to not clog things up here. So that now we have something that looks like this. So still not really great because the terrain here is actually pretty phenomenal, but you wouldn't guess that from looking at this. So what I'm going to do is I am going to play with my stretches. And basically what a stretch does, it takes your image histogram, all of the values in your a histogram, and it stretches them out so that you see more contrast. So the point of stretching is to develop and create contrast. I'm going to go back to this for a moment so that we can talk about some of them. I kind of skipped ahead and I got ahead of myself a bit, which is not new. But we have all of these different types of stretches available in ArcGIS Pro, and underneath each one you can see what it is that they do. It kind of describes the concept of each. But again, what we're doing is we're taking the histogram of that image and stretching it out. So like even if you look at this, black and white image, because the pixel values are kind of close together, you don't see much contrast. But when you stretch them out, notice how it kind of brightens up the image, and you can kind of see and distinguish features from each other a bit better. So again, there's various stretch types available in ArcGIS Pro and in ArcGIS Online. In ArcGIS Online, they are limited to the 3 that you see here, but in Pro, we get a lot more options. My go-to stretch is not listed on here because it's not available in ArcGIS Online, but the one that I'm a really big fan of is the histogram equalize stretch, because it tends to the most consistently make for a really nice looking rendering. But there's no one right answer for which, or no one way to determine which one's going to be the best for each data set. Each data set is different. You basically just it's a trial and error thing. You just try the different stretches and see which ones work the best for your data set. So a couple of other things that I want to mention that are available and really handy tools in both ArcGIS Online and ArcGIS Pro is what's called DRA. And basically what DRA is, it's dynamic range adjustment, which means that it will only use the pixels on screen and display those on a dynamic basis. So if you zoom in and out, it will adjust the stretch for those pixels that you see on screen and not the ones that are off screen in the image. So again, by using DRA, it really just enhances your imagery. And then the gamma helps create contrast on those mid-level gray values. So it's just, again, a nice little tool to be able to use. And then again, here are the what these stretches are and what they do, and when you might want to consider using them. So I would encourage you just to kind of go through these and read the descriptions associated with each of them. So let's get stretching. So here we are back at Bighorn Canyon National Recreation Area, and we want to make an awesome DEM. So what we're going to do is first come to our DEM and go to the stretch type, and I'm going to select histogram equalize, And notice how that already has done a significant amount. I'm going to do the same thing to my underlying hillshade. Now look at that. How awesome is that? And that was just by applying a stretch. Again, it's just taking that histogram and stretching it out over the range of values that are available. Now if I turn on DRA, and I'm going to zoom in a little bit to do that, turn on DRA, notice again how that kind of sharpens it up, and then as I zoom in, it is just applying the stretch to both of these images based on the pixel values that are shown on screen, and it's ignoring the ones that are off screen. So again, that allows for more contrast to be created, which then makes it easier to distinguish features on the Earth's surface. So these are some of the things to play around with when you are creating your terrain for Yellowstone National Park. You can play around with the various color schemes, and I mean, when I first found the color schemes, I must have spent hours just changing colors. So I hope, hopefully, actually, you'll fall in that same trap because it's a lot of fun. And then also by changing stretch types. So I'm actually going to just change the stretch type so you can see some differences. And again, when I do it, I'm going to do it for both of the data sets so that they're using the same thing. And you can see how this one may not be as effective for showing terrain. And again, I'll go back to histogram equalize for both so you can see the difference. So that is a little bit about the concept of stretching and using dynamic range adjustment. So coming back to the PowerPoint and maybe going back to all that stuff that I just managed to skip over. In the intro class, you learned how to create a number of elevation data sets, and just as an FYI and a reminder, you need to have the 3D Analyst and Spatial Analyst extensions to create these data sets, and all of which you have. However, just because when you go into the workplace, like when you get a job after going through the program, not all organizations have access to these tools, so it's just something to be aware of. If your organization is going to be doing a lot of terrain analysis, having either one of these extensions is going to be important. They can be found under 3D Analyst in the raster surface area, and then under Spatial Analysis in Surface. These can also be found in the raster functions area too. So there's multiple places to find these. So just again, as a reminder, and I'm not going to show you how to create these data sets because you've done it before and it's really not that hard. It's just basically filling in the tool. But slope is the degree or percent steepness of the land, and the red areas indicate steeper slopes and green indicates flatter areas. If you remember from both intro and remote sensing that you have to specify the units when you are running the tool, and then in addition to that, you have to make sure that on your map layout that you specify what units your slope is in. Is it in degrees or percent rise? That should either appear in your legend or your title or both. So make sure that your units are available, because otherwise this map is really not overly useful if we don't know the units and how to interpret it. Also, just like you saw all those elevation color schemes that I showed, there are ones that are appropriate for slope. So don't let ArcGIS Pro do the thinking for you. Make sure that you are selecting a color scheme that is appropriate for representing slope. ArcGIS Pro may give you just a default one that is not the best thing to use. The next one is aspect. This is the direction of the slope is facing. The legend is auto-created that you see here, so it's actually showing the direction that particular slope is facing. And what this is showing is the Little Bighorn battlefield out in Montana, and you can see the directions of the various slopes. And I believe Custer was in this area here, so he wasn't in the best spot. But aspect is really important for a lot of different applications such as agriculture, because certain crops grow best on certain facing slopes. Like wine has certain slopes that are grapes. Wine doesn't grow, grapes grow. Grapes grow on certain like south, I think it's southeast facing slopes. We also have hillshade, which we just took a look at, and this is a grayscale 3D representation of the surface, and then it's essentially taking in the angle of the sun, and when you run the tool, hillshade tool, you can change where the sun is located in the skies to get a different type of shadowing on there. And so in this week's assignment, I just encourage you to play around with creating different hillshades for the same data set to see how changing some of those settings impacts what your final result is. And then we have two different types of hillshade. We have the traditional and multi-directional. The traditional calculates hillshade from one single illumination direction, and where you are controlling the azimuth and altitude of the light. So this is what you're going to see, and these are the defaults. These are the ones that I'm suggesting changing, and just to see how that impacts what gets created. And then the multi-directional combines light from multiple sources to create an enhanced visualization of terrain. So it may be neat for you to try to do a comparison of what that looks like. And actually we can do that with our example here. So I'm going to come back to this one, and I probably should have done the comparison before I did all the stretching on the initial hillshade. But if I want to do the multi-directional hillshade, you would access that by going to your imagery, and then go to raster functions, and then your raster functions come up. This is an area that we go over in more detail in the remote sensing class, so you'll see a lot more about this then. But there's a number of surface tools available here. If I go to hillshade, notice that we can input the raster, which is the DEM, and then we have the option of creating a traditional and a multi-directional. And actually what I'm going to do is I'm going to shut off these two, and I'm going to create it both ways from scratch. So let's do it by traditional, and then let's come back here and do boom, multi-directional, and boom. And already you can see a difference there. You get a little bit more depth with, and let me just close this too so you can see it even better. Let me use my fun little swipe tool. We have all such sorts of cool tools, don't we? And you can kind of see the difference there. And again, what you might want to do then is go to your stretch type, and it's asking if I wanted to calculate statistics in a histogram. Sometimes when you create new rasters, it doesn't the way that I created it there was using raster functions. This data isn't permanent data that exists on my computer. If I want to keep these, I have to right click on them and export them. So because it was created in the way that I did, the statistics in histogram weren't automatically created. So that's what this is doing. But while that's doing it, because it seems like it's taking it a while to just, oh, it's not letting me click. Raster functions are a little bit different in terms of how it creates data than what they are in Toolbox. In Toolbox, you have to specify an output location for your data, and you have to name your data. So you're creating new data. What we did here in raster functions is we ran the tool, and it created these, but it never asked us for where we might want to put this on our computer. So this is just existing within this particular project. So this data is not saved anywhere. If we want to save it, we would have to right click on it and go to Data, Export Raster, and export it as its own file. So you can see what the histogram equalize did there, and I'm not sure if I like that or not. So I'm going to try a percent clip to see what that does, and I kind of seem to like that one a little bit better. And I'm going to do then the same thing to this one. And again, it's going to take a few minutes to calculate statistics, and I'll babble while it's doing that. But going back to the exporting of these, do make sure you are aware of that so that it's not something that frustrates you later because you didn't save it as a permanent file. The benefit to this is that it allows you to experiment more, I think, and the data sets are created more quickly, so because it's not calculating those statistics and histogram, so it allows you to kind of play around with the parameters more to get a result that you want. So kind of why that's like that. So now that's done running, and again I'm going to grab my swipe so you can see the difference between the percent clip on the multi-directional and the traditional. So pretty cool, right? And then, you know, what we could do, boom, boom, drag that sucker up there. And we can add the coloring to it. And that's what it looks like with that one. And that's what it looks like with the other one. So lots of fun time just, you know, playing around with all of these settings to get something that looks good. Over here you also have your other really more basic contrast settings like layer brightness, so like you can, you know, pull this up and down, and this is the layer brightness on my digital elevation model, so it's the one that's selected. And notice that how you can really make that kind of some cool effects there as well, and you can you know, change your layer contrast here. So spend some time just again playing, because really that's how you learn this stuff, and this is how you create nice visualizations. And my suggestion to you, since we are in this Zoom environment and you're probably chatting on Zoom a lot, save one of these as your Zoom background. A really quick way of doing it would be to, you know, go to your share, and then you can export your map as a JPEG or TIFF, or the way that I do it, because I'm super duper lazy, is I come here and do a new snip, and this is in the way, I think, which is why it's not letting me do it. But I do a new snip and then capture the screen, and yeah, my video is just getting in the way of it, so it's not letting me do it. But then a really quick way of creating something. So going back now to the PowerPoint. So we went over all of these various tools again in previous classes, but again to remind you, Paint It Relief is the combination of the DEM and Hillshade, and it tells you how to create that, and again the areas to create that in. There's also another way of generating a shaded relief that just requires the input of the DEM, and again that's found in the same place where that multi-directional hillshade was found. It's found here, and you get something that looks like this, and what looks like I did on my cover screen. So let me just quickly show you how to do that. And again, the DEM is the one I'm interested in. I'm going to go to Imagery, Raster Functions, open up my raster functions, go to Shaded Relief, and input the DEM, which is this one. You can select your color ramp here, and I'm just going to keep the default there, and then hit Create New Layer. And you get then something that looks like this. So if we wanted to keep this, then we would right click on it, go to Data, Export Raster, and then save that to some location on our computer. So that's another way of generating a shaded relief, and it's actually a really nice way to do it. Contours are created again from your surface tools in 3D or Spatial Analyst. Unlike all the other data sets, slope, aspect, hillshade, and so forth, contours are vector data. They're not raster data. Vector data means that it's either a point, line, or a polygon, and these are line files, and essentially what contours do is connect like elevation values, and you specify what interval that you want, and it's based on your particular data set. When you do create a contour data set, my suggestion is when you are creating them, you name them with the contour interval in it. So if you are creating 50-meter contours, you call them like Bighorn Canyon or BICA for short, contours 50 meters, so that when you go back to add that to your map at any point, you remember what interval that you used. Also, just a little bit of a warning about labeling contours. By default, ArcGIS likes to take the first number field that it finds to label contours, which is not the right field. It's the ID field that it selects by default. Make sure you're changing it to the contour field. Also, you might want to note in ArcGIS Pro, there are tools for labeling your contours a little bit more nicely, and I'm just going to quickly generate some contours from this particular data set. So again, come over here, search for contours, and the input is always the digital elevation model because that's the starting point of terrain analysis. I'm just going to keep it called this for a quick demo. I look at the elevation range here. So the closer those values are together, the smaller you would probably want to make your contour interval. The larger apart they are, probably a larger one. And I'm just going to try 100 here. And again, this is 100 meters that they're being created in because that's our source data. And then I'm going to hit run. So here are my contours, not really overly beautiful. I'm going to just quickly symbolize those a bit to change the color, to mute them a bit. I'm going to just and I'll probably do transparency on them because that's going to be a little bit much. And I'll just keep it there just for demonstration purposes. But what I want to show here is, again, having to do with the labeling of contours. When first, go to your Label tab. Remember here the default field that it selects is the ID field, which isn't necessarily the right thing. You have to make sure you select contour there. Secondly, it gives you some new improved options for labeling contours. So if you select contours here, you're going to see that you have those options. So I'm going to right click on it and go to Label. It's going to be really probably painful in the eyes when it does it. And it's just taking a second there. And then again, I would probably mute the label color and size and so forth. But again, the point that I'm trying to make is that there's labeling schemes that allow you to label contours nicer than what we could have done in ArcGIS Desktop. So explore your labeling options when you are working with your contours. So going back again to the PowerPoint, so that's a little bit about contours, and then viewshed. And I'm not really going to go deeply into viewshed here, just because cartographically there's not too much to talk about. This is more an analysis thing, and we cover that in a different class. But viewshed is basically what can be seen from observer points. So this point over here is where Custer was when where his body was found, and so you can see what he was able to see from that position. And there were tens of thousands of Native Americans down by the river, and which he could not see almost any of that, hence why what happened. But these are found in the same place as the other surface analysis tools. So that's a little bit about working with digital elevation models. Now I want to just talk about working with imagery in ArcGIS Online, and I'm going to focus mostly on satellite imagery, but the same concepts apply to aerial photography. It's just that with satellite imagery they have more bands of data available than you would with an aerial photo. So in remote sensing, for those of you that took it, you've learned how to work with Landsat imagery and how to find and download these. And one of the really cool things that has come along is how to add Landsat imagery to an ArcGIS Pro project, and how it makes working with the imagery a lot easier, rather than having to create composite bands out of all of the individual band data. So what we do with that MTL is we drag it from our catalog area to our content area, and then our image is available for us, and then we can go to band combination to set our various band combinations. And when we get here, we are going to see all of these options available here, and it tells you what those band combinations do and mean. And after you select any particular band combination, we can do exactly what we just did with digital elevation models. We can apply stretches and so forth to that, and you can also do some resampling. And resampling is sort of, in terms of image enhancement, it's sort of similar to stretches in that it just allows us to render the data in different ways. So I would explore some of those. Again, what we're doing with these stretches is stretching out that histogram of values in the image, and we already talked about this, so I'm not going to go over these again. But when working with satellite imagery like Landsat data and digital elevation models, there are some other image processing tools that just make your life easy. And if you go to your imagery tab and then go to process, you're going to see all of these options here. Similar to how raster functions work. You know, I just said that you create something with raster functions, it doesn't create a permanent data set. The same is true here, is that if you use any one of these, it will put the data in your table of contents. However, if you want to keep it, you have to export it out to be its own data set. And I happen to really like some of these in terms of how quickly you can get what you need. In particular, the clip and mask. And they're basically kind of like the opposite of each other, where the clip keeps whatever is in the viewing extent and the mask removes what's in the viewing extent. So going to here and then going to here, and I'm going to turn off those contours so they stop hurting my eyes. Let's say that I want to clip my DEM right here to just what I have in this area here. I can go to my imagery and then go to process and clip, and it will automatically clip that DEM just to that particular area. So when you have to clip a DEM for something, this is a super easy way of doing it. Likewise, as I said, the mask kind of does the opposite of that. What we can do is, if we want to kind of put a hole in something, so let's turn that off and let's kind of do this. Let's say that we want to get rid of everything that we see in here. We can go to Imagery, Process, Mask, and now if I kind of zoom out here, and let me just turn off everything else. There's too much other stuff on. I had to zoom. I had the wrong thing selected. That's why it's doing that. So let me do that again. My apologies. So again, let's zoom in to this and make sure that it is selected. Go to Process, then Mask. And then I'm going to turn off this one, zoom out. See how we have that hole now in there. So like for Yellowstone, like maybe if you want to clip out Yellowstone, that might be a nice way of doing it. So those are some really fun, easy tools to use. You can also do mosaicing here as a quick way. I showed you the other way. This is another way of doing mosaicing. So just know that those tools are available and can really, you know, make you more efficient in your image processing. And then the last one is image masking, and I like this tool. I just think it's kind of fun. And again, using Yellowstone as the example here, let's say that you want to show what's outside of your area in a little bit of a different way, but you want to really be able to focus on what's in the middle. You can actually kind of clip that out by doing image masking, and this doesn't actually alter any of your data. And let me go here, and what we would do is again go to our imagery tab, or is that appearance? Oh, the appearance tab, and go to masking, select Yellowstone, and select Yellowstone. And there we have it. It just takes it a second to do that. So again, this might be is a nice thing to do when your area of your map focus isn't in here and you don't want to clutter it up with imagery, but you want to have some type of imagery on the outside. This is a great way of doing it. And then of course, just with this imagery, we could do the stretches and the color schemes and so forth. So I hope some of this was helpful in terms of how to use some of the image analysis tools or image rendering tools. There's another thing posted in the course or the homework area that's called Terrain Tools. I'm going to create a separate video showing you how to install this and how then you can use the various tools that are in this Terrain Tools toolbox.